So in this video, we're going to be talking about topic 0.5, and we are going to be looking at trig functions of any angle. We're actually going to split this into 2 separate days. So you're only going to learn to do half the lesson today. And I'm going to probably split it into a couple of different videos here. So first thing you want to do is write down your essential question. How do you evaluate the trigonometric function of any angle? And the I can statement, I can find the values of a trigonometric function given the value of one trigonometric function. I messed this up. Okay. All right, let's see if I got it better now. So, first of all, we've got the definition of trig functions at any angle, and we have basically seen this already. It's an angle on the coordinate plane. You need to basically find the triangle. Oh, that is way too thick. Let's go back to that. Let's try that. That's better. So you find your triangle. Doesn't matter what quadrant it is in. This is always the reference angle. The opposite is still there. The adjacent is still there. But in this case, since we're on the coordinate plane, the horizontal will always be our x, and the vertical will always be our y, no matter which quadrant we are in. So it wants us to find the exact value of the trig functions of any angle. So I'm going to draw my triangle. I noticed that this leg, I know it seems weird, but because it is in quadrant 2, the x value is actually negative, and it shows us that there. The y value is still positive. I do need to do the Pythagorean Theorem to figure out this calculation here. So in case you don't remember it, it's -3 squared plus 4 squared equals r squared. Okay, so -3 squared is 9, 4 squared is 16, equals r squared. 9 plus 16 equals r squared. And I'm going to take the square root of both sides. Your hypotenuse will always be positive, so you don't worry about the plus minus on the hypotenuse. Now I'm ready to find my 6 trig functions. So I've got the sine of theta equals, and here's my theta, opposite, adjacent, hypotenuse. So opposite, which is 4 over hypotenuse. I get my cosecant for free because I just get to flip it. And then the cosine of theta equals the adjacent -3 over the hypotenuse 5. And the secant we get for free because I just get to flip it around. So -5 over 3. The tangent of theta equals the opposite 4 over the adjacent -3. Doesn't matter that you put it in the denominator or the numerator or just float it out front. It's fine for the negative. And the cotangent we get for free by just flipping it. You'll notice, remember, all students take calculus, only sine and cosecant are allowed to be positive, and check it out. That's actually what happened in that quadrant. All right, we're going to try this again one more time, just so you get the hang of it and you see it in a different light. Notice this one was drawn for us. This one they're not going to draw for us. They're expecting us to kind of draw it ourselves. So I'm going to make a sketch of that. This time it says it's out 2 and down 3. So there's technically this is the angle, but this is the reference angle part. I know that I am out 2, but I am down 3. I'm going to go ahead and do Pythagorean Theorem to figure out what my hypotenuse is. So -3 squared plus 2 squared equals, we'll go with x. X isn't a good idea. R squared, radius squared. So -3 squared is 9. 2 squared is 4 equals r squared. 9 plus 4 is 13. And then we take the square root of both sides. So r equals the square root of 13. Again, I would probably write on there that this is the opposite, this is the adjacent, and this is the hypotenuse. Probably drew it way too small. So I'm going to find the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent. So the sine is the opposite, -3, over the hypotenuse, square root of 13. I'm going to flip that, and then I'm going to choose to rationalize. So I'm doing the flip, then I'm doing my rationalize step. So that way I I don't rationalize multiple times, okay? All right, my cosine is the adjacent 2 over the hypotenuse square root of 13. So this would be 13 over 2, okay? And then I'm going to rationalize this part, which gives me 2 square root of 13 over 13. Finally, I've got the tangent, which is the opposite, -3 over the over the adjacent 2, and I just flip that for my cotangent.